Hey everybody, this is Larry. This is day 11 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join my Discord, and let me know what you think about today's poem. Today's poem being remove duplicate letters. Okay, this seems straightforward if the name is what it is. Given the string S, remove duplicate letters so that every letter appears once. The result is the smallest lexicographically amount all possible. Okay, so this makes it a little bit tricky. So for these final problems, so I mean, the remove duplicate letters itself is straightforward. It's about which one to remove and which one to keep, right? And for these problems, the way that I would think about it, and I'm thinking about it now, is just think about the invariant, right? And I think, let's see. Yeah, and I think there's some sort of greedy, but we have to try to figure out how. I think the way that I would think about it is, I mean, it's gonna be some sort of greedy-ish thing, so that's what I'm trying to think about. So what I'm thinking about now is just different type of greedy algorithms and trying to think about what works and what doesn't. And also, if you're joining me now, you might notice that I'm solving this live, so I might not go through the solution directly. I'm just going through what my thought process is, which is maybe more interesting for problems like this, where it's greedy, and I'm just going through in my mind different things, right? And for me, the invariant and me trying to figure out now is that if there's an A, you want A first, and then if there's a B, you want B second. And you want the B to be as early as possible, right? After A. That's the invariant, is that after A, put it B, after A, you put the B after A. Otherwise, you put it as early as possible, right? So it's, so I think that maybe all we need. Because the property that I'm trying to withhold is some sort of greedy, where we want to put the A as close to the beginning as possible, then the B as early as the beginning as possible, after A, and then C as possible. But then, in this case, C, but then the D would come after C, right? So there's a little bit weird thing. So then, so I'm also trying to think about how to do this without backtracking, because there's 10 to the 5th characters, right? That's a little. Good thing, among all possible. Okay. That is a tricky one. And then sometimes I think about if I could do about is there we can do about it backwards, where like D, we want D to be the most behind possible, but then I think you end up just doing the same thing but backwards, which I don't know. Like, how do you know between the B to put in the front and the end, right? So that's interesting. So I don't think I do know how to do this one off my immediately. Maybe it's a good thing to warm up on. Because even in this case, right? So yeah, BC, ABC, but let's say this is about a C, right? Then you can't really. Then the answer is actually BCA, right? Because now, instead of, you may think, some kind of CAB or something like that by another greedy. So I think there are a couple of things that we have to consider as well. I mean, I think one thing to note is that because this is lowercase characters, there are only 26 characters. That may be something that we can exploit to keep track of. And given that this is only 10,000, maybe we could do some kind of dynamic programming with respect to the shortest character up to now. But that seems a little bit messy. Because are there subprompts that are very easily directed? Okay, so in this case, let's see, right? Let's do, maybe there's a sliding window thing. So CBA, right? So let's say, right, we start with C, we go with the B, we go with A, and that's fine. And C appears, right? Well, that means that we can move it to the back, so then it's BAC maybe. But then how do you do, BACD, and you add another C? Well, you want to keep the C here, but that's, and then the B, you want to move the B to the back, so then it's ACDB, and C, you don't move it to the back. Does that make sense? I think I'm going to give it a try. To be honest, I don't know this one immediately, but I'm going to give it a try of the invariant around the sliding window, of just adding one character at a time. And then if you see a duplicate character, you just see to see if it makes sense that it is in the position that it is in the string, or the new position, and then just keep on rolling forward. I think I'm going to try that. I'm not confident about this, so I may be wrong in this one, so definitely bear with me. These type of greedy problems are always a little bit tricky. So yeah, let's just say current string. Let's just say it's empty string for character in X or in S. Let's just say C and S. We want to do some kind of quick lookup. Right now, I'm just going to write it naively. You could do optimizations that makes things a little bit quicker, but it should be okay if C and S, because there are only 26 characters, right? C is in current. If it's already in current, then we check. What do you want? I mean, so we want something like current sub. Okay, so let's say index C equal to the current index. Is it index of or index of C? And current is equal to current something index plus current index plus 1, let's say, right? Something like that to remove the character, and then plus C. And then else current is equal to current plus C, something like that. And then we had to do a check actually. This is not true. We don't remove it unless so possible or candidate may say candidate is equal to this. If candidate is less than current, then current is equal to candidate, right? I am not confident about this at all. I need to warm up a little bit maybe. So that's definitely not right. So maybe I have some typo, because I thought I did this by. Oh, I thought I did this manually, but because then this is the sliding window, and BCA is better than C, so then you don't do the C, but then the C, so then it'll be BAC, right? Yeah, that's not right then, the way that I'm doing it. The invariant does not hold. So definitely, they all, with greedy, stuff can be wrong. So, and it's a good thing that I get caught on the sample cases. But now I don't have an idea. Let's see. I mean, I don't have an idea other than like some kind of exhaustive backtracking. But 2 to the 26 would be too slow. So, I think for this one, like I said, you're trying to find an invariant that makes it that's good. But I don't know. Thinking about, okay, A, you always wanted A to be the front, but as we said before, it's not always possible that A is in the front, right? Like if we just have this, then the right answer is something like BCA, right? So now I'm just thinking about different ideas around forced characters. Like in this case, A is forced because there's only one A, but I don't know if that I can get anything from that. I think maybe there's another invariant, which is that can we I think maybe some sort of insertion sort. Does that make sense? Basically, I have some idea around, for example, this B is no good because for this B to be good here, you need the C and the D behind it, right? But I don't know how to do the inverse of that to be true. Because in this case, you have CDB, but then C. Huh. I guess I'll take a look at the hint. Greedy add one missing character. That's what I was trying to do. Bit mask is annoying, but yeah. I mean, that's basically the idea I had, but I just couldn't figure it out in terms of the invariant. Man, I haven't done a live taping in a while, and the first one I do, I mess up, so It's okay, let's say we have A. Well, I guess there's no world in which A makes sense. No, that's not true, right? Because if we put A, we could put B, but then if we put the B here, then the C would have to be in the front, which is why you want the B here, right? So can we do it backwards? I think one thing that I haven't done enough is doing things backwards. So C, you put in the worst things possible, so it's in the bottom, and then now you put the B. Can we do that here? Yeah, let's say we do the C here, right? Well, now we start with the D. So we put the D. So we want a C that's before the D, and then we want the B that's before the A, or before the C, and then but then the A is bad, right? So how would you know to choose this B without knowing about the A yet? I mean, this is, I don't know, maybe I'm misreading this, but so I'm trying to also obviously not do it without exponential times, so, oh, my computer's a little slow, but I guess I guess this is similar to what we said, but with this thing, except for that we have to look ahead. So I guess we could do a prefix or suffix sum of what's possible, and then when we insert, we'll see. I guess that's fast enough. I thought that may not be fast enough earlier, but But maybe I didn't do the suffix sum thing. And then how do I do it, right? Well, let's just write the suffix possible array first, which is, let's just say 0 times n, where n is the length of the s. And then we start from current is equal to 0, say. And then for index in range going from n-1 to 0. And basically here we actually technically want m, oops, plus 1. That's what we always do. So then now the suffix of index is just equal to suffix of index plus 1, or 1 to shift by the ordinate value of s sub index. I guess let's just now I was gonna enumerate it, but how did you see? Minus ordinal value of a, right? That match the brackets. Okay, so this should be okay. Let's take a quick look. Okay, so that looks good. Okay. And then now, now we want to remove one character at a time. Such that well, we could remove A because A, we know that the remaining characters are there, right? But in this case, A is not good if like in this case, in the case that we talked about earlier. Wow, this is a tricky one for me, to be honest. Maybe I just haven't thought about it this way in terms of suffix strings. But you cannot remove A, so you could remove B, because to the right of B contains A and C, which is all the remaining characters, right? Okay. And then we could go for 26 times. I think that's it. So we want no, I mean this suffix array, though I don't know if So what do we want to look for, right? So let's see. So all the characters, okay. So target is equal to suffix sub 0, because that gives us the bit mask of all the characters that are used. And then now we want to look for the earliest character that has this property. So okay, so for x, okay, so okay, I think I got it. Enter is equal to do or result, just to keep it consistent. And then we go for so we do a for loop for a number of unique characters. So okay, so while true, say we do for x, it's in s enumerated, while target is greater than 0, say, then. Okay. If the suffix of index and the target is equal to target, then what happens? That means that the suffix contains all the targets that we want in a bit mask. This is going to be a hard one to explain, but and then that means that we want to get the lowest character for it. Best is equal to none. Well, best is equal to, say, I don't know. Is that said? Best is equal to, or if best is greater than suffix or than x, then best is equal to x. Right? So we get the earliest character for which this is true. Okay, and then at the end we add that to the best character. We append it so that we take this off, and then the target will flip one of the bits, which is this thing. Best. Right. This is a character, so we have to convert it to 1 to 26. Okay. Maybe that's okay. Let's see. If the time limits, that means that something is wrong with one of my recurrences. Okay. Or let's do if best is equal to ZZ break. Maybe this is wrong. No, this should be right, but I'm really struggling with today's problem. That's okay. From time to time, everyone's going to struggle a little bit, and that's what practicing is for. But I don't know why. Let's pick up the one loop, but print target. Did I do that one? No, I mean, I get the A first. That seems like that's what I want, right? Now that looks okay on the first iteration. And if we don't find it, then that's not great, but that's okay. Why is this infinite loop then? Oh, because you keep on adding A's. That makes sense. Okay, I was actually spotting that way then, but okay. And the character X, I need a helper. Okay. Try to 26, say. X. Return order of X minus order of A. So then this becomes way easier to read. Also shorter to type. And basically we want this character to not be in target, right? So I probably could have done this with just sets. I don't think I need bit set for this, but well, that's unfortunate. Oh, I think that I did this wrong. It's greater than 0, not that is equal to 0. Oops. Basically, if this is in the target, if the character is in the target, then we want to add to it. Okay, this is way optimistic, so I don't think that's right. Because then the I think I added. I think I added it okay. I just added it in the wrong place. Okay, so that's fine. Because the B, is added at character 4. Okay. Ooh, this is a tricky one. So we also need to keep track of. Yeah, okay. I mean, I think this is okay, but we have to keep track of index. Best index maybe is equal to index, right? And then and we can just, this is, now we want an array. We we want to append it with a tuple of the best and best index and then the best, so that at the end we can just sort it. Sort by, so that it sorts by the index, and then now we want to return the string that is joined by x for the index x in result, something like that. I think that's a string, right? Oh yeah, that's a character, so that's okay. Okay, well, that didn't go as expected. Wow, this is, that was close. But my invariant isn't true, which is that, well, basically what is happening as soon as I see this is true, I know why, is that this C only looks for D, so then this really early C is, you know, good. But we want the latest case that is true, so so I think in this case, instead of this, we want to okay, so if best is equal to x, then best index is equal to index, something like that, so that we optimize for the later one, which still doesn't work. Because we do A and then B requires the C and the D in the behind, but then basically we're looking for the latest characters such that, wow, I am just really wrong on this one. Let me refresh and rethink my approach a little bit. I guess it's good that I didn't do this, whatever, but you think about this for a second. I think right now, and sometimes this happens, which is that when you have a wrong greedy solution, do you think, and this is what I'm thinking right now, is whether I can fix it or that I have to start over and refresh. And sometimes it will take me a little bit of time. I mean, I think the invariant, I think I have the invariant, it's just that I have to kind of think about how to hold it, because clearly my invariant hasn't been holding, so that was not good. But yeah, I feel like I'm close, but I don't know. Let's see. I think maybe I have to do something different with the suffix string, because the way that I did it is a little bit of a hack. So that's why and then I just hacked it with more index. That is annoying. Goes A. Okay, that's everything on the suffix. That's good, right? Now no A B C D. So A is the first character to be added, I think. Maybe the index stuff is weird. Without the index, what was it again? It's just A, B, C, D because it's A, and then B knows that C and the D is behind it, so then it just adds B, but then it doesn't take account that this B is after A, right? Or before A. and we want it to be the latest one. But the C here looks good. C should be the next one. Is that why I'm Should I go left from right? No, because this C also has inclusive of all the characters and you don't want this first, right? So then the invariant is, okay, CBA is the best so far, and then after we enter C, well, does C still become before this? Then yes, then you get BAC, but I think this is like similar to our sliding window one, but then I'm not getting that right. Wow. And then BACD is just straightforward. The C, well, you never do it. And then ACDB. But in this case, that would just be because of the greedy. CAB move to the back. No, I don't. I think I was just. Maybe my first solution was right. The sliding window. I think I just maybe had an off by one or something. Because the C should move to the. Oh no, because BCA keeps in the front. So then when you get to C, it becomes BAC. No, that's not right. That's why. This is awkward. Yeah, I don't know. This is a pretty tricky one for me. What's the hint again? Could you try to add one missing character? How to... This isn't even comprehensive. How to check if adding some characters will not cause problems? It's true. Basically, why is this... We add A. Okay, that's good. Okay, I think... No, I think this is roughly right, but I had a wrong interpretation of it. I think what I should do is... This should just be a loop. No, I mean, I think I know what I want to do, but I'm still having trouble validating that. Because C, for example, why would you not put C in the front? Because it has all the suffixes in the afterwards, right? Well, C would be a good character, but then now you have to do A, right? And then how do you choose between, even in this case, B and the C? Well, B is better, but then I don't know. Man, I'm really struggling this one. Man, I do not know how to solve this one. It's one of those days. Maybe my criteria is wrong. What do I have again? We want the latest in the B. Why is this B? Oh, because the B is before the C and the D, and we optimize for. I think I have to do one more thing. Is that for the best index? Okay, so let's say we have best index here. Then we go from index in range of 0 best index. Is that inclusive? I guess so. Doesn't matter, I think, actually. But we set the suffix of the index as equal to 0 so that we don't use the prefix. That's the point of taking all this stuff. I think I missed that. I think I missed this, and it took me a while because I think I missed the point of taking the suffix and checking that as the latest thing is because of that. Okay, let's try some more test cases. Let's try an obvious one. Let's try 2 obvious ones. Empty. Just bang it out. Oh, whoops, missed the close string. I think I was mostly right, except for that I forgot to reset this thing. Okay, so no 0 character string, that's fine. You never know, because sometimes these constraints are wrong. Okay, so that looks good. Ooh, no, this is wrong. On a random case, excuse me, why is this wrong? Also in this case, we don't need to sort anymore because by definition it won't go to a later one. But why does it choose Y instead of K? Now I need a more. I mean, I know that Y is whatever, but let's print results for a second. Really struggling with this one. It's okay. Wait. 7. 2. So A. So B has to be 0. That's fine. And then A, and then the K instead of this E. Oh, because if it's the same character, we chose the later one. Did we want that? I think we did before, but we messed up this thing. So I think that was just a hack that I left it in. Okay, now that I removed that hack, this is actually good. Okay, this code is terrible, but let's give it a submit. Would not recommend this at home. Okay, so yeah, so I think the lesson here is try to find that invariant, but sometimes you know, just because you have an invariant, you just have to hold it to be true. And here we're trying to find the latest or for me the earliest character, like from A to Z wise, the earliest character that can the subsequence can still be have all the letters, right? And from that, I make sure that we don't go backwards. I think that's it. That's why I had some issues here. And here, I guess this is just a string. But yeah, the code is a little bit of a mess. So to kind of recap, and some of this is just for performance purposes, so it's a little bit weird. But to recap, the invariant one we want to do is that for this loop invariant, right? We want to get one character at a time. The character we want to get is the earliest closest to A character where the suffix contains all the other characters, right? And that's pretty much all this does. And I do a little bit too much math on the bit mask. I think in Python you could actually just use regular sets, and these operations will probably be slower for sure, but reasonable. But basically what I do is, okay, so for each suffix, if it has all the elements of the target, which is what this bit mask does, and that this is actually, I don't think, necessary anymore. I think I used it for another no, I guess I still need it. Yeah, but basically this is if the current X we haven't done yet, then we check to see if it's the best one, and then we also zero out all the stuff in before, because we know that the suffix contains all the other characters, so you don't need it anymore on the later loops. I could also have started S from the best index, I guess, but yeah, and this is just to trigger back on. This is probably not the best explanation video, but I hope you learned from it as I did. I think I had some issues with kind of expressing the invariant that's in my head and articulating it, and that is a key part of solving these problems. But yeah, that's all I have for this problem. So let's go over the complexity. Because we get one character at a time here, it's going to be at most 26 loops, and for each of the loops we look at each of the character ones, so it's going to be O of 26 times n, which is O of n. In space we actually do this suffix thing, so it's O of n. I think you probably could do some math around you could probably do some math around keeping track of the latest. Now that I think about it, you could do some math around bookkeeping, around keeping track of the latest that a character appears, and then you have O of 26 space, which is O of 1 space. But the way that I did is O of n space. This one's a little bit of a mess. That's on me. Hope let me know if you have any questions, because this is a tricky one. And the invariant is this that we try to hold. Yeah, let me know. I'll see y'all tomorrow. I'm a little tired. Bye bye.